Welcome to the second part of refraction through prism. We have arrived at the equation delta angle of deviation is equal to I plus E minus A, where I is the angle of incidence, E is the angle of emergence, and A is the angle of prism. Here onwards, we are moving to a practical data. The practical data is when we plot a graph between angle of incidence I and angle of deviation delta. When we plot a graph between angle of incidence I and angle of deviation delta, we obtain a graph like this. It's a practical data, it's not theoretical. So, drawing a graph between I and delta, the graph will be like this. From this graph, we have to choose the minimum value of delta. This is the minimum value of delta. This minimum value is technically called as angle of minimum deviation. This is represented by D subscript M. So, the minimum value of delta is called as angle of minimum deviation, and it is represented by the letter D subscript M. And practically it is also obtained that if delta tends to dm, in this particular situation, I will become equal to E and R1 will become equal to R2. It's a practical data, it's not a theoretical one. We will obtain this data from lab. When delta gets its minimum value, angle of incidence and angle of emergence will become equal. Thereby R1 and R2 also become same. From using these identities, these equations, we can rewrite this equation. When delta tends to dm, I and E are same, therefore I plus E is equal to 2I. When delta tends to dm, I and E are same, therefore I plus E become 2I minus A. This is the expression for angle of minimum deviation. This is the expression for angle of deviation, and it is the expression for angle of minimum deviation. So when the dm represents angle of minimum deviation. From here onwards, we are going for Snell's law of refraction. For that, we have to calculate I and E. We know that I is equal to E, therefore dm is equal to 2I minus A. From this equation, 2I is equal to dm plus A. 2I is equal to dm plus A, therefore I is equal to dm plus A by 2. We obtain the value of angle of incidence. We know that R1 is equal to R2, therefore it can be taken as R. Ready? In the previous video, we know that A is equal to R1 plus R2, therefore A is equal to R plus R is equal to 2R, therefore R is equal to A by 2. Ready? So, from this equation, we calculated angle of incidence I and angle of refraction R. Then we can use Snell's law. Snell's law is sin I by sin R is equal to refractive index N2 by N1. So, sin I by sin R. So, replace I and R. We know the value of I and know the value of R. Therefore, sin, what is I? dm plus A by 2 by sin R, what's R? A by 2 equal to n. This is the Snell's law in the case of refraction. There are three equations in this equation. In the last video, we have arrived at delta. Angle of deviation delta is equal to I plus E minus A. The second equation is angle of minimum deviation. dm is equal to 2y minus A. The third equation is Snell's law in the case of prism. Sin I, instead of I, we can write the value of I by sin R. Instead of R, we can write the value of R. Sin I by sin R is equal to refractive index.